We're going to take a look at the handout that I gave you in class. We're not going to focus so much on this format, the a times x minus h squared plus k, because all of your things from the handout can be pulled from this format. We are going to focus on the bottom format, this one, ax squared plus bx plus c. That's when your function is in that format. You can see one that I've pulled up here, just a very basic quadratic function, f of x equals x squared plus 7x plus 10. And what we want to look at is we want to look at all of our parts that we have. As you can see, this works just like the quadratic formula. We have a equals 1, b equals 7, and c equals 10. Now if you notice, all the things that I ask you to find are in the form of h and k. So somehow we're going to have to come up with h and k from our new function. If we look down at the bottom, we actually have a formula down here that we can look at. This one. This is the Vertex formula for things that are in the quadratic form. And notice that I've already pulled out a, b, and c, so we can take this and plug into our Vertex formula the minus b over 2a down here. Let's start a new piece of paper. Or minus b over 2a. Minus b over 2a. If we take our numbers and we plug them into the formula, b is 7 and a is 1, so we would have negative 7 divided by 2 times 1, which is 2. So we would have negative 7 halves. Now this value is actually the h value. So we've been trying to find h and k. We now have the h value. In order to find the k value, what we want to do is we want to take our original function that we had, which was x squared plus 7x plus 10, and we want to substitute in our h value. So all I've done is taken negative 7 halves and placed it everywhere I see an x in the function. We can actually put this in our calculator and make sure we have an accurate answer. I've just typed this into my calculator, I've hit enter, and I get negative 2.25. Since the other one is in a fraction form, I'm going to put this in fraction form too. So I'm going to hit math, enter, enter, and I get negative 9/4. So now we have an h value and we have a k value. H is negative 7 halves, k is negative 9/4, and we can go through everything on our handout that we have and fill those values in. When we look at the vertex, it says that the vertex is h and k. So we actually have a value for the vertex now. We have the vertex of negative 7 halves and negative 9/4. That's our vertex. And that's it for finding the vertex. To find the line of symmetry, we have that's a vertical line, that's x equals h. Well, we have a value for h. It's negative 7 halves. So for our line of symmetry, we have x equals negative 7 halves. When we look at concavity, we want to look at the a value. Remember that a was 1, so a is greater than 0. So we are actually concave up. Take a look at your handout. You should have it there in front of you. This is a parabola, and all parabolas have a domain of negative infinity to infinity. So this one will have a domain of negative infinity to infinity. We've already decided that our problem is concave up, and our handout tells us that the range for concave up is k to infinity. We have a value for k, which is negative 9/4. Notice that as long as we have values for h and k, we're doing well with this. We've got almost everything that we need. The x-intercepts and the y-intercepts are a little harder to find, so we'll take a look at that one next. Your handout says that to find the y-intercept, you must do f of 0. So that means take 0 and plug it everywhere you see an x, which is what I've done here. If you do the math, 0 plus 0 plus 10 equals, that means our y-intercept is the ordered pair 0, 10. To find the x-intercepts, you set your function equal to 0, and then you solve it in any of the ways that you've learned. It could be the quadratic formula, it could be by factoring, it could be by the square root principle. You could even use completing the square if it's an appropriate problem. In this one, when I set it equal to 0 and I look at it, I see that it's a trinomial and I can find factors of 10 that give me 7. Factors of 10 that give me 7 would be 5 and 2. So I factor it into x plus 5 and x plus 2 and set each piece equal to 0. This tells me that when y is 0, x is negative 5 and x is also negative 2. So I have two x-intercepts. My ordered pairs would be negative 5, 0 and negative 2, 0, since for the x-intercept y is always 0. You would show your x-intercepts in ordered pairs. The last thing that I ask you to find on this handout are the extreme values. Now, the extreme values are just another phrase for the local minimum and the local maximum. It says if the graph is concave up, then k is the minimum. If the graph is concave down, then k is the maximum. Well, we've already determined that ours is concave up, so that means that k is the minimum. And you can see we list it. Here's k at x equals h. That's how we list a minimum or a maximum. And we would have to say that it was a minimum because we wouldn't know otherwise. So we would list it just like that. Just make sure you have your handout in front of you and go through each step of the process. Find h and k first. Once you've found h and k, everything else falls into place.